number system. Now in number system we have four types of number system. Okay, first is decimal. Now decimal is a number system that we use, that is 0 to 9, right? So this is the number that we use in your maths and your daily life. Okay, you always use these numbers. So it's, what I mean is that it doesn't mean that we use a single digit of 0 and 9. Suppose if I take 567, I'm using 5, which is in this range, 0 to 9. I'm using 6, which is in this range, 0 to 9 again, and 7, which is in this range again. So all the numbers that we are using falls under this, okay, this range, that is 0 to 9. And if you count all these digits, that makes it 10 digits, and that is the base of the number of this particular number system, and that is decimal, because we have 10 digits. Now what is base? Base always tells you what kind of number system that particular number is, right? So now let's say if I say 25, let's say example, give 25, and just beneath it I just write 10, okay, in this way. So this 10, what it signifies is that it signifies that it is a base of this number 25. So immediately you will know that this is a decimal number system. So base basically is for that, right? So this is a base for this, right? And the digits that we use is 0 to 9. Okay. These are the digits, right? Now similar way we also have other number system, okay, that is binary. Now what is binary and why? Of course, like decimal, we understand that this is what we use, but binary, why are we using? This is a number that a computer uses, that already knew, that is 1 or 0, isn't it? So these are the only digit that we have. So basically if I say the digit in binary would be 0 or 1, okay, or 1 or 0, and if I say the base would be 2. Why? Because there are 2 digits, right? 2 digits, that is 1 or 0. An example would be a combination of 1 and 0s like this, okay, but we usually, the base now of course would be 2, because 2 digits, right? So we have 2. So immediately when you see number like this, it means it is a binary. So this one is the one that we use, human being uses, right? That is the decimal, and this one is what the computer uses. Apart from this, we also have octal and decimal. Now why do we need these two number system? That's because there's a shortcut way of converting, okay, a binary to these number system and vice versa, from these number system to binary. And why do we need to convert? That's because you know that a computer understands only these two, and that we are writing in these numbers, so we need a conversion, right? So basically just because of that, we also have these other number system, that is octal and hexadecimal. The same way we have particular digit assigned to them, okay, right, like we have for binary, we also have for octal. Now octal, the digit would be from 0 to 7, okay, so any number that falls under this, okay, that is an octal. And its base, now if you count all the digits from 0 to 7, that makes it 8. So basically, if again let me use 25 again, because 2 and 5 can be in this range, but if the base is 8, then it's not a decimal, okay, it's not a decimal number system, it is a octal. And the similar way we have a hexadecimal. In the hexadecimal we have 0 to 9, that makes it a decimal. And then comes, then the alphabet comes from A to F. Okay, so basically if I just take the entire thing, actually it's 0 to 15, right? But we don't write 10 as 10, we write 10 as A, 11 as B, and 12 as C, so on and so forth till 15, and 15 is F. And if we count from 0 to 15, we have 16 digits. Okay, this part is decimal and the rest is 6. That's why it is called as hexadecimal. Hexa for 6 and decimal for 10, right? And example again would be, of course even 25 can be in hexadecimal because we have 0 to 9. So we can have something like this, or maybe some combination of alphabet. Of course till F you have. So you may have something like this, E, then 12, and then again it would be G's 16. So these are an example of hexadecimal number system. So these are just the introduction part of different number system. Okay, in the next video I'm going to show about